Everyone thought electric vehicles were the final answer to clean transportation, until Cummins unveiled something no one expected. Not a battery, not a fuel cell, but a revolutionary engine that is clean, powerful, and shockingly efficient. This is not science fiction. It is real. And it is already shaking the foundations of the EV world. If you thought diesel was dead and electric was inevitable, think again. Because this new clean engine may just rewrite the future of transport forever. The legacy behind the breakthrough. Cummins has always been a name that meant power and reliability, but now it means something much more. Born in the small town of Columbus, Indiana, in 1919, the company began with a simple ambition: to build dependable diesel engines. And over the next century, it quietly built one of the most respected legacies in heavy vehicle manufacturing. Claus Lyle Cummins, the man behind the name, was not just an inventor but a visionary who believed diesel could change the world. His early prototypes were met with skepticism, and the market was dominated by gasoline, but he persisted. In a daring move, the company sent one of its diesel-powered trucks across the country from New York to Los Angeles, proving that diesel was not just powerful but dependable over long distances. That journey changed everything. What began as a garage project turned into a global powerhouse. During World War II, Cummins engines powered countless military machines, earning the trust of the U.S. government and paving the way for industrial dominance. By the 1950s, Cummins had already become a household name in the world of transport and heavy machinery. They expanded beyond America into Latin America, Europe, and Asia, making their engines a global standard for trucks, buses, trains, and ships. In India, they partnered with Tata and launched Tata Cummins in Pune, revolutionizing the trucking industry across the subcontinent. This partnership showed the world that Cummins was not just about building engines but about building relationships that fueled economies. But Cummins never stayed comfortable. While competitors stuck to what worked, Cummins poured billions into research and development, chasing efficiency, cleaner power, and smarter machines. As the world began shifting toward sustainability, Cummins pivoted, not by abandoning engines but by evolving them. They began to explore hybrid power systems, alternative fuels, hydrogen technology, and emissions-free solutions, without giving up the raw power their customers relied on. They understood that the future was not just electric. It was diverse, flexible, and adaptable. So when the world saw the first whispers of Cummins's new project, most people were caught off guard. There were no leaks, no teasers, no hints, just silence. And then suddenly, the X15N engine was announced, a machine designed for the clean fuel future. A natural gas engine that was so powerful and efficient that even electric proponents had to pause. Not because it looked different, but because it challenged the very narrative of what clean transport was supposed to be. But the story is not just about an engine. It is about a company that saw the writing on the wall before anyone else. While everyone else was racing toward batteries and electric grids, Cummins quietly asked a different question. What if there was another way? What if we could have all the benefits of clean energy without the limitations of electric vehicles? And from that question came an answer that has now taken the form of one of the most important engineering achievements in years. The X15N engine is more than a product. It is the culmination of decades of forward-thinking engineering, and the living proof that sometimes the best innovation is not abandoning the past, but transforming it into the future. Now, with the spotlight squarely on them, Cummins has made it clear that they are not just here to compete with electric vehicles. They are here to provide a realistic, clean, and powerful alternative. And for the industries that rely on massive fleets, long-distance hauling, and heavy-duty logistics, this new option could not have come at a better time. Electric might work for your daily commute, but the world of transport is much bigger than cars. And Cummins has built an engine to prove it. What exactly makes the X15N so revolutionary? And how is it already changing the minds of even the biggest electric vehicle supporters? The birth of the X15N. Power meets clean fuel. The X15N engine did not appear out of nowhere. It was the product of years of research, development, and a deliberate shift in how Cummins approached engine technology. The company knew that the global conversation had changed. No longer was it enough for an engine to be powerful or even fuel-efficient. The demands of modern transportation had evolved. Policymakers, regulators, and the public were now asking for something that once seemed impossible: raw mechanical power with near-zero emissions. That paradox led Cummins engineers to imagine an engine that could deliver traditional output while being cleaner than ever before. And so began the development of a natural gas engine unlike anything that had come before it. Named the X-15N, the engine was quietly developed with a focus on fleet operators, governments, and commercial buyers who needed real-world solutions, not theoretical promises. And the first thing Cummins did was abandon the idea that diesel was the only way to get high torque and horsepower in a heavy-duty vehicle. They looked to natural gas not as a secondary option but as a future-ready fuel source. Compressed natural gas and renewable natural gas offered the kind of scalability and infrastructure compatibility that many electric and hydrogen systems still lacked. And unlike battery-powered trucks, which struggled with long-haul weight and recharging downtime, the X-15N could run efficiently for hours and be refueled in minutes. But the real genius of the X-15N lies in its versatility. It was designed to fit directly into existing truck chassis with only minor modifications. This meant fleet operators could adopt it without overhauling their entire vehicle systems. For companies running hundreds of trucks, this was a major win. The cost of replacing every vehicle in a fleet with an electric truck was not just expensive, it was operationally disruptive. Cummins offered a cleaner way forward that did not require businesses to pause. They could upgrade their engines, keep their trucks, and move into the future on their terms. In terms of output, the X-15N delivers up to 500 horsepower. That alone puts it on par with some of the most powerful diesel engines on the market. But power is only half the equation. What makes this engine truly transformative is its ability to maintain that level of performance while running on renewable fuel. This opens a pathway not only to carbon neutrality, but in some cases even to net negative emissions when paired with certain renewable gas sources. And all of this is happening without sacrificing reliability, which has always been a key concern for long-haul logistics and commercial trucking. Cummins also built the engine with digital integration in mind. A smart engine control module constantly monitors fuel input, load, torque output, and temperature to ensure optimal performance. If anything deviates from the norm, the system self-corrects. Power with near-zero emissions. That paradox led Cummins engineers to imagine an engine that could deliver traditional output while being cleaner than ever before. And so began the development of a natural gas engine unlike anything that had come before it. Named the X-15N, the engine was quietly developed with a focus on fleet operators, governments, and commercial buyers who needed real-world solutions, not theoretical promises. And the first thing Cummins did was abandon the idea that diesel was the only way to get high torque and horsepower in a heavy-duty vehicle. They looked to natural gas not as a secondary option but as a future-ready fuel source. Compressed natural gas and renewable natural gas offered the kind of scalability and infrastructure compatibility that many electric and hydrogen systems